All right, going to introduce you to something new today called vectors. We'll tell you what that is on the next slide, but understand what we're going to do with vectors. I'm going to show you the math behind the vectors and let your physics or chemistry teacher give you some applications. We're not going to go so much into applications, we are just operations with the vectors. So there you go. First of all, vector. All a vector is a directed line segment. It's a line segment that has direction, and it also has both magnitude, which means it has length, and direction, which in our case today is going to be the slope. Two vectors are equal or equivalent if they have the same magnitude, same length, and the same direction. So half the day we're going to be talking about are two vectors equivalent or not, and the other half we're going to try to find what's called the resultant vector. Okay, initial point, terminal point. Initial point, remember, a vector is a directed line segment, which means it has direction. The initial point's where it starts. That would be the, I'm trying to draw there. There would be the initial point for vector AB. There's initial point for CD. There it is for OP, and there it is for vector V. Now, one thing about the vectors, they also have terminal points. Now, even though there's arrows, you see arrows on the end of these vectors, those arrows do not represent the fact that they go forever, because they don't. It's a line segment, which means it has two endpoints. Those arrows tell you what the directions the vector is moving. So it's actually going that direction. It doesn't go forever. It's not a ray. It doesn't keep going. It's just direction. All right, next one is show that all three of these vectors are equal. Now, to show that they're equal, you must show two things. You have the same length and the same magnitude or length and the same direction. So the first thing I'm going to do is I'm going to find the distance formula for each one. So vector u would look like this. I'm going to say the square root of, I'm subtracting my x's. I'm going to do this in my head. 2 minus negative 1 is 3 squared, which is 9. 4 minus 3 is 1 squared, which is 1, so I get square root of 10. Now, if these are going to be equal, I should get the square root of 10 for each of these. So I'm going to try vector OR next. OR. I'm going to try this one. Now we get square root of, do the same thing. Do my x's. 0 minus negative 3 squared is 9. 0 minus negative 1 is negative 1, or 1 squared, which is 1. Add them up, I get square root of 10 again. Not a surprise. And then vector W, same deal. Distance formula. Subtract your x's. 4 minus 1 is 3. Squared is 9. Negative 1 minus negative 2 is 1. Squared is 1. So I get square root of 10. So far, so good. But remember, for them to be equal or equivalent, they have to have the same direction also. So I got to check the slope of all three. So on U, I'm going to do the y minus y, which is 4 minus 3. Having a hard time with my stylus today. 4 minus 3 over, sorry about that. 2 minus negative 1. There we go. So I get 1 over 3. So I get 1/3 there. I'm going to make it a little shorter now because my stylus is having issues. OR, sorry about that, it keeps moving on me. Vector OR, if you do slope, do y minus y, you get 1. X minus x, you get 3, so it looks good so far. And then vector W, I'm going to do y minus y, which is 1, x minus x, which is 3. So because I got all the magnitudes are the same, all the slopes are the same, or directions are the same, they're equivalent. So all three of those vectors are definitely equivalent. All right, here's some that are and are not, just a couple pictures here, or 4 pictures. These two vectors, u and v, are not equal because they have different magnitudes and different directions. So everything about those first two right there are messed up because everything's different. On this one, they have the same magnitude, which is good, but they have different directions, which is bad. Remember, they have to have the same direction, same slope, and same direction. This one has a negative slope, that has positive slope. The third one down, same magnitude. I'm sorry, I'm reading the wrong ones. This one has different magnitudes, different size, so that's definitely not the same. And the last one down here, those are equal because if you look at them, they have the same magnitude and the same direction. That's a really good slide right there. It shows you a better view of what I was trying to show in the last slide. To be equivalent, they must be like this at the bottom, have the same magnitude and go in the same direction. All right, vector addition. 2 ways you can do vector addition. Vector u plus v is represented by the directed line segment for the initial point of A of u, vector u, to the terminal point C of vector v. It's called the resultant vector, is what the sum is called. Now, I'm going to show you this one first, even though I wrote it second here, or drew it second. what I did is I drew vector u here, and from the end, the terminal point of vector u, I drew vector v. And the way you get the sum or the resultant is you connect the initial point, the beginning of vector u, with the end of vector v. And that vector right there is the resultant or the sum when you add those two. All right, the picture over here is a different way. This is called the parallelogram method, where I would draw vector u going this way and use the same initial point. Like I'm using vector u and vector v from the same starting point. And then what happens if I draw a parallelogram connecting those two sides? If I connect the one diagonal of the parallelogram right there would be the resultant vector. So if you look at this picture and this picture, and if I actually had them both the exact same size, obviously, then you would see that those are the same, that u plus v has the same magnitude and same direction. So two ways to do it. If all they're asking you for is a geometric representation or the picture of it, the easier way to do it is the triangular method. But I'll be honest, we're going to end up using this one the most, the parallelogram method. So get ready to draw some parallelograms. All right, last slide here. The magnitudes of vectors u and v and the angle theta between the vectors are given. Find the sum of u and v. In other words, find the resultant. Given the magnitudes nearest tenth of the resultant and give the direction by telling the nearest degree, the angle makes that the result makes with vector u. So I wrote the information here. Vector u has a magnitude of 54. Vector v, remember the absolute value symbols, I hadn't showed you that. It looks like absolute value symbols in vector notation, that means magnitude. So the magnitude of, or length of vector u is 54. The magnitude of vector v is 43. The angle between the two vectors is 150. So it is, I drew vector u here. I drew vector v there. The one's 54, one's 43. And if you look at the angle between, it's 150 degrees. Now they're asking you to find two things here. They want to know what the resultant vector is, which is this one, the u plus v in the middle. And they also want to know what the angle is that it makes with vector u. So once that little angle, where I put the theta right there, that little angle, you can see the little arc right there. That's what they want to know. Let me make it a little bigger for you. So what I did is I did the parallelogram method. Drew my parallelogram based on, I just did this, I went parallel to the opposite sides, and that's how I get my resultant, my u plus v right there. All right, now you got to remember a little bit of parallelogram stuff here. In parallelograms, the opposite angles are congruent, and not only that, but all four angles are added to be 360. So if this angle right here is 150, that means all of v is 150. So that's 300, which means these two angles together must be 60, so each one must be 30. So that's where 30 came from right there. All right, so that's 30. That's angle A. Now to find this, because I've got a triangle now, if you look at, there's a triangle, and I know that I have an angle, and I know that's 43 and that's 54, so that's side angle side. To find the side that's missing, I can't do law of sines because I don't have an opposite angle on opposite sides. I have to use law of cosines to find out the resultant length right there, or the magnitude. So I did, a squared plus b squared minus 2ab times c cosine 30. So I punched all that in a calculator, and I got 27.3. So the magnitude of u plus v is going to be 27.3. Now I also got to find this angle right here. And once I know that side, now I can use law of sines, which is much easier. So to find this, I did opposite, which is 43, over sine of theta. And then I did, now that I know u plus v, I did 27.3 over sine 30. So I'm doing law of sines like we did the other day. Cross multiply, divide, and got right there to do inverse sine to get your angle. Don't forget to get angle. You need to do inverse sine in your calculator, and I got 52 degrees. So the two things it was asking me for, magnitude and the angle for the resultant vector u plus v. That may be a lot right there. We will definitely do a couple of these when you come in tomorrow just to make sure you have it. It's not as bad as it looks on here. I know that probably looks pretty terrible, but it really isn't. So hang in there. We'll knock it out, and I'll see you tomorrow.